Before the first atom, before the first star, before light itself. Imagine nothing. Not darkness, not silence, not emptiness. There was no space, no time, no where, and no when. The universe did not yet exist. Time was not moving. Space had no shape, no direction, no distance, no before and no after. Everything we know today, galaxies, stars, planets, existed only as possibility. And then, about 13.8 billion years ago, something unimaginable happened. It was not an explosion inside the universe. It was the birth of the universe itself. Space began to expand. Time began to flow. Energy began to spread. The very fabric of reality started stretching in every direction. In the first moments, everything was pure energy, compressed into an incredibly dense state. Temperatures were trillions of degrees. Conditions so extreme that no structure could survive. Particles appeared and disappeared in a constant frenzy. Quarks, electrons, photons. Nothing was stable. Nothing lasted. The universe was a turbulent ocean of energy, constantly changing. But then, in a perfect microscopic dance, quarks began to join together. They formed protons and neutrons, the first whisper of matter. For the first time, something could exist for more than a tiny fraction of a second. Within a few minutes, protons and neutrons combined. Hydrogen, helium, and traces of lithium, the simplest elements in nature. Simple, but essential. They would become the raw material for everything that came later. The balance was incredibly delicate. If the universe had expanded just a little faster, nothing would have formed. If it had expanded more slowly, the universe might have collapsed back into itself. The existence of stars, galaxies, and planets depended on this precise balance. For hundreds of thousands of years, the universe remained a hot, dense fog, a glowing plasma. Light could not travel freely. Every photon was instantly absorbed and scattered again. Everything was an ocean of blazing gas and particles. A bright universe, but invisible. Then, about 380,000 years later, something changed. Electrons finally joined with atomic nuclei. The first stable atoms were born. The universe became transparent, and light was finally free to travel. That light is still moving through space today, crossing billions of years of history. It is known as the cosmic microwave background, the echo of the universe's birth. A snapshot of the cosmos when it was still extremely young, but there were still no stars, no suns, no galaxies, no sources of light beyond that ancient glow. The universe entered what scientists call the Dark Ages. For millions of years, the cosmos remained in deep darkness. But this darkness was not empty. Inside it, silent forces were at work. Slowly, almost imperceptibly, gravity began its task. Regions that were slightly denser began to pull in more matter. Tiny differences in density started to grow, like invisible seeds planted in the fabric of space. Over time, these ripples grew into larger and larger structures. Gigantic clouds of hydrogen and helium began to form. Some of them were millions of times more massive than our Sunday. After tens of millions of years, some of these enormous clouds began to collapse. Gravity pulled matter inward. Pressure increased. Temperature rose. And deep inside those clouds, something extraordinary was about to happen. For the first time, hydrogen began to fuse. The first stars were born. They were giants, brilliant, violent, unstable, much larger than most of the stars we see today. Some were hundreds of times more massive than the Sunday. They lived fast and died young. But during their short and intense lives, they changed the fate of the universe. They were cosmic furnaces, factories of elements. Inside them, colossal forces crushed atoms together with unimaginable energy. Hydrogen became helium. Helium became carbon. Carbon became oxygen. And heavier elements began forming inside the hearts of stars. For the first time, the universe started building complexity. Elements that would one day form rocks, oceans, atmospheres, and life. But the first stars did not last long. When they ran out of fuel, they collapsed violently. And then they exploded. Giant supernovas lit up the cosmos. Explosions so powerful they could briefly outshine entire galaxies. These explosions scattered carbon, oxygen, silicon, and iron across space. Heavy elements were thrown in every direction, mixing once again with cosmic clouds of gas, preparing the universe for the next generation of stars. The iron in your blood was forged inside a star that died billions of years ago. You are, quite literally, rearranged stardust. The universe was no longer simple. It was becoming chemical, complex, interesting. These elements formed the foundation of everything: planets, life, and you. As generations of stars were born and died, matter began gathering into even larger structures. Gravity continued its patient work. Clouds of gas merged. Stars formed clusters. Clusters organized into much larger systems. Islands of billions of stars. Galaxies. Each with its own gravitational dance. Each slowly spinning for billions of years, each carrying the promise of worlds. Today, we know there are trillions of galaxies spread across the observable universe. Among those trillions, one spiral galaxy began to emerge. Young, elegant, still growing, its arms slowly unfolding through space. Billions of stars shining within it. But the story of that galaxy, the Milky Way, will be told in another episode. Because before any planet could exist, before oceans, before life, the universe had to learn how to make stars. It had to learn how to spread elements. It had to organize chaos into structure. Everything that you are began as primordial energy. That energy became particles. Particles became atoms. Atoms became stars. But the final stage for life was still being prepared. And somewhere inside that young spiral galaxy, a star would eventually form. A very ordinary star. Nothing special at first glance. But around it, dust and gas would begin to spin. Around it, matter would slowly organize. Over time, microscopic grains would collide, stick together, grow. A solar system would begin to form. Planets would emerge from this spinning disk of matter. And on one of them, billions of years later, something extraordinary would happen. But that is still to come. And when it does, this story will stop being only cosmic. It will begin to become personal. In the next episode, we will follow the birth of the solar system, the moment when the final stage for life began to take shape.